Welcome to The Explainer. Today, we're going to break down a really common assignment, taking an existing Java project and refactoring it to use modern, powerful features. All right, let's get right into it.
So you've built something that works, which is awesome. But, the job isn't just about making things work. It's about making them work well. Your hard work got noticed, and that's great. But now it's time for an upgrade, a real level up for your code and, honestly, for your skills.
Your mission, should you choose to accept it, is to knock out 9 specific tasks. And look, this isn't just busy work. These tasks are basically a guided tour through some of the most important and useful features in modern Java.
Now, this is super important. We're about to perform some serious surgery on our application's insides, but the user, they shouldn't notice a thing. The menu, the features, all the functionality, it's all going to stay exactly the same. We're just making the engine under the hood way more efficient and a lot more robust.
Yep, this is the heart of refactoring. We're keeping that familiar 9-option menu, but behind the curtain, we'll be swapping out older, kind of clunky code patterns with some really slick new tools like lambdas, method references, and the super useful optional class.
First up, let's tackle one of the most dreaded bugs in all of Java history. You know the one I'm talking about, the null point exception. We're going to make our code fundamentally safer using a little something called optional.
The best way to think about an optional is to picture it as a box. That box might have a student object inside it, or it could be totally empty. And the beautiful thing is, the Java language now kind of forces you to check if the box is empty before you try to open it and use what's inside. No more accidental crashes.
And this just shows the difference perfectly. On the left, in the old way, you get a value back that might be null, and you just have to hope you remember to check for it. If you forget, boom, crash. But on the right, the optional type makes it impossible to forget. That if present or else method says it all. Here is what you do if the student is present, and here is what you do if it's not. So much clearer and so much safer.
So here's your game plan for this section. First, you're going to create 2 new helper methods that wrap their results in an optional. Then you'll hunt down the places in your code that look up students and courses and switch them over to use these new, much safer methods. All right, we've tackled nulls. What's next? Let's switch gears and focus on clarity. We want to make our code more concise, especially when we're dealing with lists of things. We're going to totally simplify how we print our collections.
I mean, just look at how much cleaner this is. The classic for each loop on the left, it works, it's fine, but it's a lot of boilerplate. The version on the right uses something called a method reference. That's what that double colon thing is. It's just a super compact way of saying, hey, for every single item in this collection, just call the println method on it. It's direct, it's expressive, and it's way easier to read.
Okay, your task here is pretty simple, but it has a big impact. You're going to dive into your generic printer class, find that old loop, and replace it with that slick one-line for each version. And then, and this is the most important part, run your program. Make sure that printing students, rosters, waitlists, everything still works exactly like it did before.
Now for something really cool. This is where we go beyond just cleaning up old code. The IT manager wants a brand new feature, an honor roll list, and we're going to build it in this really elegant, reusable way using something called a predicate.
A predicate is basically just a test that you could pass around as if it were an object. It's a function that takes one thing as input and always returns a Boolean, either true or false. So for our case, the test is pretty simple. Does this particular student have a GPA of 3.5 or higher?
And here you can see exactly how that test gets applied. Our predicate is going to march through our list of students one by one, take a look at their GPA, and spit out true if they make the cut for the honor roll and false if they don't. Simple as that.
And this little line of code is the magic right here. This is the actual implementation of our predicate. It's a lambda expression, and it's so clean. It just says, hey, I'm a function that takes a student, we'll call it S, and all I do is return the result of the test, s.getGPA greater than or equal to 3.5. All that logic packed into one beautiful, readable line. So how do you actually do this? It's a 2-step process. First, you'll create a new helper method that can print a list of students that matches any predicate we give it. Then, right after you print the full student list in your program, you'll call that new method and pass in our specific GPA lambda to generate that honor roll.
All right, for our final refactoring task, we're going to tackle sorting. In older Java, if you wanted to define some custom sorting logic, well, it was a bit of a ceremony. There was a lot of code involved. We're about to change all that.
I mean, the difference here is just stunning, right?
On the left, you have this bulky, 5-line anonymous inner class. It's just a lot of noise to define one simple comparison. On the right, we use a helper method from the comparator class. By combining comparator.comparing with a method reference to get course code, we get the exact same result in one single, incredibly readable line of code. This is what modern Java is all about.
And just like that, once you apply this simple, elegant change to all the places where you sort courses, you will have officially knocked out the 9th and final item on our list. Mission accomplished.
You've done the work, you've leveled up your code, you've even added a brand new feature. Your code is sparkling. So now what? It's time to package it all up and submit it.
So here's exactly what you need to turn in. First, a zip file of your entire Maven project. Second, you got to grab a few screenshots to prove it all works. Show the menu, the student lists, that awesome new honor roll, and the course printouts. And finally, just drop in a link to your code up on GitHub.
And that's it. That's how you take a solid project and refactor it to modern Java standards, making it safer, cleaner, and just way more expressive. So take a second and think about it. Which of these new tools, the safety of optional, the clean look of lambdas, or the power of predicates, did you find the most useful? Which one are you going to reach for first in your next project? Thanks for watching.